Hi, I'm David. So for this problem, we're given two equations. 1/5 x plus 1/2 y equals 8, and x plus y is equal to 20. And they're asking us to solve for x and y through substitution. So let's recall that with substitution, we can have up to 4 different ways to substitute whenever we have two different equations and two different variables. Because we could isolate this top y and substitute it into the y in the bottom equation. We could also isolate the bottom y and substitute that into the y in the top equation. Same goes for the x's. We could isolate this x and plug it into this x here. We can also isolate this x and plug it in to the x on top. All 4 of these methods would get us the same result. So we just have to do whatever is simplest. So let's do it for the y's, because later on I want to graph these. So let's isolate the y's so that also puts in a format that we can graph later on. So to isolate the y in this top equation, we're going to subtract negative 1/5 x from both sides. That leaves us with 1/2 y is equal to negative 1/5 x plus 8. And then we can multiply both sides by 2 to cancel out the 1/2, right? Like this. So now we're left with y is equal to 2 times negative 1/5, which is negative 2/5 x, plus 2 times 8, which is 16, right? Now let's do it for this one. So for this one, it's really simple. All we have to do is subtract x from both sides. So then we're left with y is equal to negative x plus 20. And now in order to solve for x, all we have to do is substitute y in for each other, right? Since both of these equations are equal to the same variable, we can just set these two equations equal to each other. So that becomes negative 2/5 x plus 16 is equal to negative x plus 20. We can subtract 16 from both sides. This cancels this out. And we can also add x to both sides. This cancels the x's out. So then on this side, we have 20 minus 16, which means we're left with 4. And then over here, we have negative 2/5 x plus x, which would get us 3/5 x, right? Because we could take this x and change it to 5/5x. It's the same thing as just 1x, plus this negative 2/5 x. That gives us positive 3/5 x. And now in order to isolate the x, we can multiply both sides by the reciprocal of the fraction, which is 5/3. This cancels this out, so then we're left with x is equal to 4 times 5, which is 20, divided by 3. And now we can take this, plug it back into either equation to find y. Let's do this one. This one seems a little bit easier than this one, since there's no fraction involved here. So we can just take this, plug it in here. We will get y is equal to negative 20/3 plus 20. So in order to add these together, we need a common denominator. So we can multiply this by 3/3, right? That way they have a common denominator of 3. That gives us 60/3. So then we're left with negative 20 plus 60, all of that over 3. That is equal to 40/3. So our final answer would be the x and y equaling 20/3, 40/3. We can also use our graphing utility to check to make sure that these answers are correct. So we can turn on our graphing utility, go to y equals, and under y equals, for y sub 1, we can insert either of these. So let's just insert this one. So it would be negative 2 divided by 5, all of that times x plus 16. And then we scroll down to y sub 2, we can insert this. So that's negative x plus 20. And then we go to graph, and you'll see two lines appear. And that these two lines intersect each other. So we can zoom out a bit so that we can see it more clearly, since these are all pushed up by 16 and by 20. And then we can go to second trace, which is calc, go down to intersect so that we can find the intersections for the two lines. So we can select our first curve, either line works, and then we can select our second curve, just pick the other line. So now we've identified to the graphing utility which two lines we're looking for the intersection. And then we just need to guess the intersection and point it into the middle. And we'll see that the intersection is 6 2/3, or 6.6 repeating, and 13.3 repeating. That's simply the decimal version for this over here. This being the fraction version, and the version that your graphing utility gives you is probably going to be in decimals, but it's really the same thing. And that is how you solve this problem.